This episode is brought to you by Acryl Data, the company behind DataHub, the leading developer-friendly data catalog for the modern data stack. Open source DataHub is running in production at several companies like Peloton, Optum, Udemy, Zynga, and others. Acryl Data provides DataHub as an easy-to-consume SaaS product, which has been adopted by several companies. Sign up for the SaaS today at dataengineeringpodcast.com/acryl. That's ACRYL. Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Hung Dang about Y42, the full-stack data platform that anyone can run. So, Hung, can you start by introducing yourself?
So my name is Hung, and I'm the founder and also the product/technical lead here at Y42. I've been in the data industry for a long time by now. Actually, I started my PhD in statistics, consumer behavior, so it was quite mathematical and statistical back in 2013. And my mom is a PhD in statistics. My dad is a professor in sociology and statistics. So it's in the family. And I've worked with data. I love it. And that's where I am.
And you mentioned that you first started working with data in your PhD studies. I'm wondering if you can speak to what it is about the overall space and the industry that has kept you interested and how you sort of got started in industry after your studies working in the data ecosystem.
It's very important to highlight that I come from an entrepreneurial background in the sense that I studied an entrepreneurial study program in parallel to the normal studies. So it's called the CDTM. So it's an extra curriculum program that's almost like a full-time study. So it took more time to study at the CDTM than actually do my regular studies at the time in Germany. So we are just 25 people in one class. And out of my 25 people in my class, 70% roughly started a company, and we have 5 unicorns, $5 billion companies just within a class of 25 people. And hopefully, if we don't fuck it up with Y42, we'll probably be one also soon. So that being said, I come from an entrepreneurial background, but I studied in my main studies statistics. That's why I actually started a company end of 2012, which was an event company. And it has nothing to do with data, but I was running full-scale events in 20 different countries. So that was my first commercial success in my early 20s. And we ran event, from LA to Singapore to Dubai to everywhere in Europe. And we made millions in revenue in the first year of operation, but the margin was like extremely thin. So naturally, as somebody who studied data, it was my task to just collect all the data, to analyze that data and trying to basically improve our margin. And at the time, there was no Airflow, there was no Kubernetes. In that time, it was, Facebook didn't really have an API. I had to download the CSV files for our marketing spend to collect data from our ticketing platform by scraping the website. And I had to, do a lot of stuff that was very unconventional in 2012, 2013. But somehow I glued together a data infrastructure that really helped us to improve our margin from 8% to 12%. And that literally increases the profit by 50%. And so I really fell in love with the power of data. Like, I fell in love with understanding how data can help the user understand the world and also, improve efficiency. And this is why I decided to start a software company in 2016, really focusing on the live event industry, because if we manage to do that with our own events that are only 6 figures to set up, why don't we try to do it with events, that are 8, 9, 10 figures to set up. And this is something, I've gotten into, and we built a very specialized software tool to collect data, to transform data, and to build visualizations and predictions, like very tailored to the live event industry in 2016. And that's also the first time when I really learned how programming works, because before I was just a guy that would script, with R, with Python, or with Stata even, to run some, we called it regression model, and nowadays we call it machine learning. That was, a very hard journey. I mean, I started out not knowing what a constructor is and, object-oriented programming and so on. And I had to learn that along the way, just because I feel very inclined that I need to understand things on a fundamental level before I can make good decisions. And there's no way that we will build a technical company without me understanding the whole process behind it, why we have to do certain things. And I wasn't able to find a CTO back in the days who would, join on that kind of niche product or niche industry. But so we built it out. It was very hard years, but at some point we were analyzing 1/3 of all live events in Europe. And so every major Ed Sheeran, Justin Bieber concerts, major festivals, we were the tool that would analyze the data for these events. And so I was forced to serve a very non-technical audience who has a lot of data, because, imagine the 100,000 people coming to an Ed Sheeran concert, producing millions of data points. And so you kind of have this oxymoron. It needs to be very easy, but it needs to be very scalable at the same time. And I did that for until end of 2019. And I built up a lot of technical debt during that time. We weren't able to cross the chasm and really introduce that product to other industries other than the live event industry. So I was, decently successful, right? But then again, I had already a version in my head that we could build, that could serve basically any industry. But for that, really, we have to build the product again from scratch, fundamentally a different architecture. And this is why I decided to sell that company in 2019 to a German Fortune 100 company. I took the money that I made. I started a new company, which is early 2020, called Datos Intelligence back in the days, but we rebranded to Y42 along the way. And that's our story.
So can you describe a bit more now about what it is that you're building at Y42 and some of the impetus behind that particular area of focus?
We are trying to serve the audience that have been pretty much underserved by now, more non-technical users. But that's just, a very first step of what we're trying to do. Because coming from the live event industry, like I said, it needs to be a very easy and scalable solution. So what we do is we operate on top of a data warehouse, such as Snowflake or BigQuery, and we help our users to integrate with over 100 different data sources. So we integrate with other SaaS tools and pull the data into their data warehouse. We help them transform the data, having a UI model. We help them all use SQL. We help them visualize that data. We help the user orchestrate the whole flow. And we help the user also send the data back to the tools where they need it. So basically, an end-to-end data pipeline that was very optimized for the non-technical folks to use in our very first version. But that was never our end game. So the end game is, you have to remember, I come from an enterprise background, right? Like, I sold my last company to a major German Fortune 100 company, and I built the data pipeline there, or at least I had a big influence on it. And during that time, I've seen that the data industry, you have a lot of different personas working together. I think you've heard it, a lot of times by now. You have the business users, and the name already implies business intelligence, right? It's for business to make better decisions at the end of the day. And then you have the wonderful data warehouse coming up, was one of the very first users of Google BigQuery, as a matter of fact. And I fell in love with the power of it. And that's when I knew, hey, the Y42 version slowly comes up in my head. So with that being said, we have to serve, all these different personas. With the data warehouse, the data engineers come into play. Now there's this analytical engineers at DBT Coin, there's the data analyst, there's the business user. For us, it's all about really collaboration. We want people to work together seamlessly, to talk the same language. We want people to understand each other. We want it to be efficient. We want to create value. I think that's very important. We want to create value. And for value to be created, we are betting on the horse that we want to align different entities. We want processes that are superior. And I must say, there are software development best practices that business users haven't adapted that are just plain superior. And we want to bring that to the business user. So we want the business user and force them to processes that really scale, that engineers have, but also at the same time, we want business users and less technical folks to express their ideas, their wishes in a self-serve manner that the engineers can really understand, okay, that's what the end user wants. And I can build it now in a more scalable way in the infrastructure under the hood. And so this is what Y42 V2, which we're about to release end of June, will be all about. It's about collaborating, bringing the data engineers together, bringing the business user and the data analyst in one frictionless platform.
And you mentioned that the core focus of Y42 is to be able to use these scalable and well-practiced paradigms from engineering and make them available and applicable to non-technical end users. And there have definitely been a number of attempts to be able to serve that market of non-technical users largely in the form of low-code and no-code, visual drag-and-drop workflow builders. I'm wondering what you see as some of the limitations of that approach and some of the ways that you're aiming to improve upon that paradigm and make it easier for these non-technical end users to be able to take advantage of these powerful data systems without having to educate them on all of the, conditional and Boolean logic that tends to bleed into some of these visual sort of drag and drop workflow builders.
So funnily, I learned to understand data structure very well by using Tableau for the first time 8-9 years ago. It really taught me more about data structure. And I feel that Y42 is doing the same thing to the users, but not just in terms of visualization, but truly building out data pipelines. And along the way, we are very opinionated how to do things. So for example, in V2, and I think that's one of the major innovations that we are introducing to the market, is that we build our own Git engine within the web browser. So we're using WebAssembly, and we built the first extremely scalable Git engine. We abandoned all our MySQL databases that we have in the V1. So basically, we have all of these tools. We have integrations, we have visualizations, UI modeling, SQL modeling, etc. And they were all separate microservices. And they would save the settings inside the MySQL database, and they would save the jobs. Every time a job runs for, let's say, an integration, we would save the job status. Hey, is it pending? How long did this job take, etc. We would all save that inside of MySQL database. And that worked well for the V1, but we ran into a lot of limitations, such as, hey, templating becomes, very hard. A rollback becomes hard with a MySQL database. We would have to build some version control system on top of MySQL that's, very, very hard. And also environment, like setting up a dev and master branch and merging them and so on. And that was a major drawback of the V1 that we have. And so we know that now we have to build a system, and everybody would, like listening to this problem that I'm describing, everybody would say, well, then just use Git for it, right? Like that's such an obvious answer. But it's not, because we want to make it truly seamless, the experience. Most people would just think, well, then I'm just going to save settings in Git, like settings such as which columns am I going to import from, which source, or what's my SQL model. It's just like settings. But we would abandon all these MySQL databases and force the user to use one to provide us a Git repo, and we would save everything inside Git. So we would save all the job statuses in Git. And that means there's an interplay between the user creates all of the settings and committing them to the repo. And then there is our Y42 bot, or our backend, that would also commit of these jobs inside the repo. So let's say I'm on the dev branch, or I'm on a feature branch, right? Like I set up a new integration, I run this integration. It might take literally 3 hours because it's a huge Shopify or MySQL table. Then this job runs for 3 hours. I have it inside the data warehouse. The job links to a table inside the data warehouse. If it's successful, the backend commits that job inside the this feature branch, and I merge that feature branch into the main branch, and this job is instantly available without waiting for 3 hours. And so by doing that, you have the full power, of Git for version control, branching out. You have the full power of like auditing who did what, and obviously there was a lot of engineering things that we have to do in order to make it work. Like you would think of performance problems, right? Like this is massively big. We run thousands of jobs a day, and we keep committing these jobs to the repo at the same time, right? But then it's an end-to-end system that if I screw something up, I can roll back everything, like from the visualization back to the integration, because everything is as code, since we are an all-in-one data platform. So I can, let's say, create a new feature branch, create a new integration, then transform that data in that branch with my existing model, and then visualize that data, and then commit that to the main branch. And then I'm on the main branch. But then if I really screw up something, I can just roll back. And so the whole visualization, like we have the whole platform rolling back to a state. And so that way we are also capable of version controlling all the tables within the data warehouse. Meaning you can roll back to any table inside any data warehouse instantly, and the whole system would just work. So we took all of this power of data engineering best practices and hide it away extremely well for the business user. And there's like a business user mode. They don't even know, like the engineers would set up, all the business users that enable business user mode, they are working on this branch, like only on the business user branch. Or they may be committing straight to the main branch with the visualizations, but probably not the best practice. And that way, as you can see, we are enforcing a lot of engineering best practices so that the business user has to adopt them, but we hide it extremely well. And then on top of that, we do have the no-code, low-code layer to transform data, and it just blends in perfectly with the pipeline, with the pipeline that's being written inside SQL. We also are in the process of integrating perfectly with dbt. So you don't write dbt in a separate dbt folder structure. It's nested within the Y42 file system. When we, let's say, have an integration set up, well, we also automatically write it in the source YAML file from dbt. It's a very big interplay between our system and also other system. And so we allow the user, the business, the non-technical user, to use no-code, low-code, but then slowly teaching them the proper way of doing things and letting them graduate to a more sophisticated system when they're ready for it, when they want to enable the next step. So we basically peel layers of layers of layers for these users so they become more sophisticated on the way. But then again, we give all the power to the engineers that I would just use Y42 in my IDE. I don't need to use the UI for it. I can code everything in Y42 straight, just clone the repo and code it in there.
Digging further into the actual Y42 platform, can you talk through some of the overall architecture of the system and some of the underlying sort of services and functionality that you rely on from other platforms and components? Because I know that it is, to some extent, stitching together a number of the different components of the so-called modern data stack. So being able to plug in things like a Snowflake warehouse and your dbt models, and then wire that into your data visualization, business intelligence layer. I'm just wondering if you can just talk through some of the overall architecture and extension points that are available for being able to integrate across this ecosystem.
So to understand that, I want to highlight the persona that we are after. And the first persona that we are after is the first data hire in any company, that Y42 is the natural choice for them. So they don't need to stitch together 5-6 different tools. It comes out pretty much out of the box. It doesn't matter if you're a data engineer. It doesn't matter if you're a data analyst. It basically comes right out of the box. And we don't want companies to outgrow us. That's basically our strategy. So with that in mind, we do want to build a very frictionless experience. And There are many tools out there that stitch together the modern data stack that tries to build a service, maybe like Meltano, that is very code-driven, but they're using Airflow, they're using Singer, they're using dbt, and so on and so forth. We didn't go down that route. We do some of it. For example, we were always one of the guys that push forward the Singer standard for integrations. So we contributed a lot to the Singer standard. Meltano's, in fact, using quite a lot of our integrations that we build, maintain in-house. And then, of course, Airbyte comes along using also the Singer standard. So it's just a plug and play for us because the architecture is pretty much the same. We have roughly 50 of our integrations written on our own. Then there are roughly, another 60, 70 integrations written within the Singer community that Airbyte also supports. And then there are the integrations from Airbyte. So yes, we do support these integrations from Airbyte. We do support these integrations from Singer and have written a lot of our custom integrations. With orchestration, we tried to use Airflow in our first version. That didn't work out because it didn't scale to the extent we wanted to. And we just wanted to rely on Kubernetes jobs at the end of the day. So we really built out our own orchestrator, because we were forced to. Airflow didn't really have an API that we were able to use, so we couldn't use it to plug it into our system. Then we were really focused on capturing the data analysts first. And now we are in the process of serving the data engineers very well within the process so they can collaborate finally together. But our first data transformation was to support business users and data analysts to a little technical background to do basically everything you can do within SQL with our no-code and low-code data transformation. Obviously, there are not many players out there, not even any open source software. So we had to build it on our own. And now in the process of including dbt under the hood, but it's not a nice user experience. It's not at least for what we're trying to accomplish. It's not a nice user experience for example, dbt. You would need to create two different data sets for two different environments, right? You cannot merge. dbt doesn't commit the jobs inside or commits everything else inside Git, such as we do. So it makes an experience quite broken compared to what we have right now. When you want to merge it from one branch to another, you have to rebuild the tables again, running the dbt jobs. So we do integrate because dbt is a great tool. And we want to support all the engineers that already work with dbt and that can just plug dbt together with the Y42 ecosystem. But it's not as nice of a user experience as if we, let's say, build our own. Our SQL model that we have also supports Jinja. So pretty much similar to dbt, but dbt has, on top snapshots. dbt has, for example, testing. We use great expectations. So we don't use dbt tests. It's great, but we think great expectations just has. So that was a very natural choice to connect to again. And then on the visualization side, we wanted to have everything in code. So we use eCharts from Baidu, which Superset is also now using eCharts under the hood in the next iteration. So that's an open source library from Baidu. And it's still open source, but one level of abstraction lower than using any modern data stack tools such as, Superset. And then on reverse ETL, it's an 80-20 kind of game. Most of the users, with 10 reverse integrations, you literally cover 90% of all the use cases. That's what we're seeing right now. So now Airbyte also, has invested into the reverse ETL player by just recently buying, I forgot the name of the company, but then we will also integrate with Airbyte there. So, we choose and pick whatever makes sense, and we're really optimizing for a frictionless experience. And sometimes tools make sense, such as Airbyte or Great Expectations. Other times it doesn't make sense, and we have to build it on our own.
And in the process of doing that selection of what to take off the shelf, what to build in-house, I'm wondering, what are some of the most sort of difficult decisions to make? Are there any particular layers of the stack that are more challenging than others to either select a useful tool or understand what are the trade-offs of actually building this ourselves? And then in that process, particularly the sort of integration layer or the components that you've had to build in-house, what are some of the biggest engineering challenges that you've had around that?
So we are very product and customer centric always. So we always think backwards. And tooling is just a means to an end, really. Like, I think it became clear the last 5 minutes. So I think the hardest decision for us is what to do with DBT, because we can integrate with DBT. Like I said, the experience is not on the level that I want it to be. So I would rather build out everything DBT kind of has with Jinja is already there. We already run all the jobs. Our orchestrator knows all the dependencies already. So I don't need to trigger a model from DBT down like upstream and knowing that it has to materialize all the tables beforehand. And so it's not as native as I want it to be. But at the same time, DBT is a great tool and it has such a great community behind it that there's no way for us not to do it. And this is why with going with something where it's not to the standard I want to. And so over time, I'm pretty confident that we will still build two versions alongside. One is way more native, not as feature rich as DBT yet, but a much more native experience that our users enjoy more within our platform. And yeah, I think that's like the hardest decision that we have to make in terms of picking off the shelf or integrating or building it in-house. And then in terms of challenges, there are many, many challenges. First of all, the product surface is huge that we have. So that alone is a huge challenge. But we have the advantage that we were able to raise a lot of money early on. We're in Germany, where we don't have to pay $200,000 for a mid-senior engineer. I think the price range is rather around $70,000. We have all the ease which we can collaborate with, from East Europe all the way to Asia, where the time zone difference is not 12 hours compared to the US. So there's a huge advantage being a tech-first company in Europe with a lot of funding. You attract great talents, and we are way more engineers than we are anything else in the company. So like a lot of product surface. Then our latest challenge is funnily not in the back end. Well, I mean, backend is super, super hard, right? Like you have to move terabytes of data. We run hundreds of thousands of jobs. So obviously we have to master infrastructure, and we invested a lot into our infrastructure as code using, Terraform, open telemetry to, observe the stack and, all the, I would say, engineering best practices. We just have to adopt. Otherwise we would die within that process. And then, auto scaling, massively hard, because when we run an integration and it just takes like 1 day to import, right? Like we have to do resumable imports because we have to stop and then, scale up and down. And that's not an easy task. We have to remember the state. So there's many challenges across different tools that we have to solve. Naturally you would think, oh, all these challenges are in the infrastructure and in the backend. Yes, they are. But at the same time, we face a lot of challenges on the front end side, like building our own, Git engine. On the client side, building like a UX that people would understand, hiding the complexity of it, dealing with a huge repo that might be like 12 gigabyte that you have to clone within the front end. And so I think there are equal challenges across the board because we are a UX first company. We are a company that enables collaboration, and that needs to take into account that UX has to play in the game. So to sum it up, really master our infrastructure, master the backend, master the front end side, master UX, master product. So a lot of things that we have to take care of on a constant basis.
Particularly with that focus on non-technical users and the fact that these are very engineering-heavy systems, what are some of the sharp edges and failure modes that you've had to automate around in order to be able to maintain that positive experience for the end user, and some of the cases where you have had to maybe simplify the capabilities of the system to prevent people from ending up in failure modes, or some of the ways that you're able to turn some of the failure conditions into a useful message that is understandable by somebody who doesn't have deep knowledge of all these systems?
So let's say you're a business user and you would use our no-code, low-code layer. It's quite type safe. So if you change the name or the type or whatsoever, we know that it will have implications on the downstream model when you change something here. Obviously, we also have to run tests or so-called expectations. Hey, we expect this column to not be null. And so that's like the processes that we have for the user to trace back the error. I mean, the advantage that we have is we're truly end-to-end. So we understand like that something might break in integrations or during the transformation process, or maybe during the visualization process or whatsoever. And we build out a lot of data lineage, observability functionalities, because it's an all-in-one data platform where we own all the metadata. So it's really easy to trace back errors within our platform and find the source, like the true source of failure.
With the fact that you do have that whole end-to-end experience and you own the metadata across those stages, for people who might have an existing data platform, or maybe they start at Y42 and they start to expand boundaries of what you offer out of the box, what are some of the capabilities that you have for being able to either integrate with those external systems and be able to maintain the metadata internally, or being able to integrate or extend from your platform to be able to support some of those external systems without losing that sort of single experience or a single pane of glass to be able to view what the state of the world is across your entire platform?
So definitely more difficult because we are at the mercy of the different tools, what metadata they give us, right? So let's say there are some integrations that Airbyte doesn't have or we don't have. So we need to use Fivetran for it. And so we would build that inside our orchestrator. There's like one task or one node in the orchestrator in your DAG that you say, hey, I'm triggering the Fivetran API to trigger the table, and I need to keep polling because they don't have a webhook. So I need to keep polling, hey, is that done? Is that done? Like, is the integration finished? And then afterwards, we would do the next step, maybe a transformation that runs using the table that Fivetran has. So we integrate with other tools by just within our orchestrator calling an API and poll for the status. We can do the same for like within our DAG, we can trigger an Airflow run and just keep seeing, hey, are we successful with that Airflow run or are we not? Or an Airflow run could trigger our orchestrator, and we can keep telling, or we can even, after it finishes or fails or whatsoever, there's a webhook, we can do further actions with that as well. So I think the magic ingredient here to integrate well with other systems within our orchestrator as well, that other system can call us. So all our APIs are available. And as a matter of fact, it's funny that one of our major focus now is all of these aggregator use cases. So there are companies that need to programmatically set up their, like they need to onboard 50 different clients a week or offboard them. And there's no way they can do that with like stitching together 5 different tools. So they use our system to replicate that. So we have to provide them all the APIs, to trigger the jobs. We use Git for everything so they can template the entire data pipeline very easily and then programmatically set it up for every client. And the only thing the client needs to do is then to authenticate themselves with Facebook ads, with Google Analytics, whatsoever. So we save the token and then we encrypt that token and save it inside the Git repo so the jobs can run successfully and pull the data and then transform that data and visualize that data for them. So that's like a huge use case for us now that we can replicate data pipelines programmatically en masse. So Y42 is basically very extendable and you can program it. But if we leave our ecosystem and let's say you start to create tables and then you're using Tableau to connect to these tables that we create inside your data warehouse, obviously it's very hard for us to trace at that time what further actions is being done in Tableau. Maybe that a calculated field got added or, they join different tables together. And that's something that we haven't been able to manage yet too well. So, yeah.
RudderStack helps you build a customer data platform on your warehouse or data lake. Instead of trapping data in a black box, they enable you to easily collect customer data from the entire stack and build an identity graph on your warehouse, giving you full visibility and control. Their SDKs make event streaming from any app or website easy, and their state-of-the-art reverse ETL pipelines enable you to send enriched data to any cloud tool. Sign up for free, or just get the free t-shirt for being a listener of the Data Engineering Podcast at dataengineeringpodcast.com/rudder. For people who are actually building with Y42, can you just talk through the overall process of maybe getting set up initially and then starting to onboard onto the platform and build an example workflow? So maybe I want to start ingesting data from my application databases and my SaaS platforms. I want to build a business dashboard to understand, what is the status of my KPIs for my organization, or I want to pull in all of the data from my application databases, and then I want to do a reverse ETL workflow to be able to export my users into MailChimp so that I can update them about different product updates.
Yeah, I mean, the modern data stack would be stitching together, Fivetran, dbt, Snowflake, Looker, High-Touch, Airflow, whatsoever, what you just described. In Y42, the general process would be you generate a new company with Y42. And the first thing that you have to do is you need to generate a new space. So the space, there we ask you for three things. First of all, either Git repo, either hosted on GitHub or GitLab. And we need a database, so it can be Snowflake, BigQuery, and we need a storage, so it can be S3, Azure Blob Storage, or Google Cloud Storage. These are the three ingredients that the user needs to provide us in order to work with Y42. So now let's say you set it all up, then you never have to touch your data warehouse again if you don't want to. So you would then go to the tab integrations. You integrate the data source in a few clicks. You would configure integration settings, such as which column, which table do I want? Do I want it to be an incremental update? Do I want it, to just append, upsert, whatsoever? Then next, you would create a model, and you can decide, hey, do I want to build a UI model with drag and drop? And then it's our JSON format that compiles down to hyper-efficient SQL queries. Or do you want to just write SQL for that and join and manipulate all those source tables that you got in? And then you have these tables and you have the lineage, you can trace it back. Then you can go to the visualization tab, you create a new dashboard, you create a new visualization, and then you select the tables. Could be a model or could be a source table that you select. And then you would just create, visualizations on top of that with a drag and drop UI. And soon you can write SQL commands also there because it just returns a table. And then you can just plot it on an X and Y or Z axis if you want it three-dimensional. And then the next step is you want to automate that. So you go to the orchestrator and you say, hey, I want to automate the whole process for this dashboard. So you would just import all the dependencies from the dashboard all the way back to the source, set up, a clone expression, which obviously is hidden in a very nice UI, which the week do I want to select at what time. Then after you're done with that, preferably you go to alerts and you set up a couple of alerts. If an orchestrator and integration fails, then status failed, then send me a Slack message, send me an email to this team, or send me a webhook or when it succeeds, do whatsoever. And then on top of that, you also set up tests. Like you say, hey, I expect this column to be not null. And then you build all of that within the orchestrator. And then you can be sure that, the pipeline, is as stable as you want to invest in. You can provide a lot of tests and a lot of alerts, etc. And then at the end, you can say, hey, I want to have we call it data export. You don't want it to sound too fancy as reverse ETL. So you kind of export that data back to where you need it. And obviously, we don't have as many as High-Touch, right? Or as Census. And we don't have to. Like I said, it covers 10 exports, covers pretty much 90% of the use cases. And soon, obviously, we can do the same, such as integrating the way we do it with Fivetran. We just call the API from High-Touch and tell them, hey, this table is fully done now, the revenue table or the customer table. Please send it back. We don't have yet, maybe such as, I don't know, MailChimp or whatsoever. So that would be the process.
As far as the collaboration aspect, you mentioned that some of the core product focus is to be able to support this interaction of very technical users and engineering, code-focused people who are working on the platform with these business users, whether they're, product support, analysts, C-suite executives, and being able to have native interfaces for people on both sides of that, technical, non-technical divide or sort of along that continuum. I'm wondering, as far as the actual collaboration interfaces and abstractions that you've built in, I'm curious if you can talk through some of the ways that you've thought through the interactions among those different end users and how they might use the platform differently, but being able to say, for instance, I am a data engineer. I'm going to add in some governance controls to ensure that this PII data is not accessible to an end user to be able to expose in a dashboard. And then as an end user, I want to be able to request additional access for being able to build a private dashboard for people who have the necessary roles or attributes to be able to view that, and just some of that overall collaboration across these different roles in the organization and the types of kind of controls and interaction patterns that they might have as they're building these various workflows.
Unfortunately, we are not super advanced there yet in terms of optimizing the user interface or different success paths for different personas. We do have two different modes. One is the business user mode, where we hide away all the Git, complex Git functionalities. In the engineering mode, you can use the command line tool within our app. You can use, like all the hardcore Git functionalities, or even use our CLI tool to generate new integrations, models, and so on. So we just have these two modes for now. But I think what's very interesting is we should look at it from the lens of, hey, what's like the modern cloud era bringing us in terms of collaboration possibilities? So in the cloud, I think something like SAML, like SIM, like using Okta, using, single sign-on, like this helps greatly to predefine your teams, your users, like very basic stuff such as, hey, I have a comment and resolve functionality in the cloud. I have single sign-on. I have access control. Like this user or this team has access to this table or this visualization or this orchestration. There is, like a lot of, let's say, fundamental things that a commercial product should offer in order for the user to collaborate well. And that comes with the advancement of being able to work on the cloud. And we have also functionalities such as ownership of asset, like, hey, I'm the owner of this integration and I need to recheck it every 3 months or whatever interval. Is that still up to date, like verifying. And these are just like small things that makes a huge difference in the way people collaborate. And I think the core collaboration layer is really, hey, you can trust your pipeline. You can always roll back, you have version control. You can, do pull requests and see what the other person is doing, whether approve that or not. So you have more mechanism to like hold each other accountable, but also in case of failure, rolling back. So that makes collaboration easier because people are more confident to move ahead. And then, access control is super, super important, access control on everything. But we're not access controlling on column level. That's important. We only access controlling on table level. And that's like our single source of, truth, because like a widget is accessing this table, or even a data export or a reverse ETL is accessing a certain core table. So we just protect the tables, like this user or this team has access to, like, permission to read or write inside this table. Then for collaboration, we're trying also to take the best practices of the modern data stack, making things very modular, like a very modular setup, integration, modeling, and then there you can have the staging and the MART layers. And then in the staging layer, the engineers should, work with SQL. In the MART layer, you have the data analysts using either SQL or the UI model. And then for the business leaders, they use the visualization or the data export wherever they need it to be. And then also for the technical users, you can use your IDE to code it, or command line tool, like I said, use the front end, a graphical user interface. Both contribute to the same Git repository. We try to make, models reusable and do data like tagging very well and data cataloging. What does that mean? Does this metric belongs to this model? And you shouldn't use it again, like make it reusable. And a lot of different dimensions where we can really accelerate the collaboration process.
The most important piece of any data project is the data itself, which is why it is critical that your data source is high quality. PostHog is your all-in-one product analytics suite, including product analysis, user funnels, feature flags, experimentation, and it's open source so you can host it yourself or let them do it for you. You have full control over your data, and their plugin system lets you integrate with all of your other data tools, including data warehouses and SaaS platforms. Give it a try today with their generous free tier at dataengineeringpodcast.com/posthog. Another interesting area to dig into is because of the fact that you have moved to storing everything about the platform in source control in this Git repository, there are a couple of potential edge cases that come in. One with the ability to branch and then other people committing changes to the main line, and then you end up with potential merge conflicts and being able to reconcile those. But also because of the fact that you're dealing with data systems and you're driving modifications to these systems through this source controlled project, and you might create a branch to be able to experiment with different modifications to the table structure, for instance, how you're able to reconcile those side affected changes with this sort of snapshot in time. If, for instance, I create a branch, I experiment with a different set of statements to be able to create a new table or modify an existing table, and then I decide that I don't actually want to go that path, making sure that you actually clean up some of these externalities to make sure that it matches what the repository says it should say. So, I create a new table in this branch. I say, actually, I'm going to get rid of that. I delete the branch, making sure that I then actually go and clean up the additional tables that are created by that, since there is now no longer any reference to those tables in the repository as it exists after the sets of changes.
I mean, you already answered the question. That's exactly what we do. So you can imagine that we run jobs. Everything on our platform is a job, an integration, a model, an alert, a job, like a test, an export. It's all a job. It takes the settings of the user and it runs a job. And when it's a job to create tables in the data warehouse or update it, if it's a successful job, we reference it to a table. It's basically a hash of the timestamp. There's a signature basically of that job on that. And it doesn't matter. We basically work in the same data set. It doesn't matter in which branch you are. You work in the same data set. So I can run a job on the develop cluster and, we run this job and it has the signature. And so if I then delete this job out of my Git repo, then we would also delete that table inside your data warehouse. So there's a cron job that basically checks all the different branches and it checks the repo and sees, hey, which table are still active, which tables can we basically delete out of the Git repo, and on top of that, delete then these tables inside the data warehouse to keep it basically slim. And what we also do is we have to modify the Git protocol a little bit. So we want to really clean up the history for the jobs. Like we want to keep the jobs, let's say you want to keep them for 3 months. So we have to go within the Git protocol and see all the commits that, the Y42 backend or the bot did. And we could do that because it's just one commit. And then we could clean up all the commits that have been committed for jobs that are longer than 3 months and that are not being used. So it's being cleaned out of the Git repo and it's being cleaned out of the data warehouse as well. That's the one part that answers the cleaning out part question. And then the merge conflicts. Well, let's say I do have a merge conflict. Now that's interesting. I absolutely agree with you. We haven't solved it great yet. So the simplest case is you just accept yours or accept theirs if you have a merge conflict within a SQL model. So you are running basically, you're merging. So you ran on one branch with one SQL statement and you ran that job. And it creates a table inside the data warehouse. Now you ran another job, which was running on the other branch, and it created another table inside the data warehouse. So you have two tables now inside the data warehouse, and then you're merging the two jobs together, and we're basically also hashing the settings. So the settings in this case is the SQL command, or the settings would be the columns that have been selected and so on. And if we see that this hash doesn't match the signature of the table that we save, then you need to rerun the job again. And we would know that this job is not a valid job for the current settings that you have. I hope that answers your question.
Yeah, it definitely does. It just points to the complexity that's inherent in all of these systems.
Yeah.
And so as you have been building and growing the Y42 product and working with some of your early design partners and customers, what are some of the most interesting or innovative or unexpected ways that you've seen it applied?
We have like a lot of different types of clients, from a car wash in Brazil all the way to the biggest, tax agency in New Zealand. So really, really different types of companies that weren't able to access, like the modern data stack before using our tool up until now. And yeah, they build like, really crazy use cases with their data, but it's still reporting use cases mostly, right? Like they're not sophisticated enough to run machine learning models on top of some tables that they create. But it basically allows them to understand the business in ways they haven't been able before when we get access to the systems, because they ask us to, debug stuff for them. Then we also understand their business in ways that we never thought would be possible. So it's more on a content layer rather than, wow, look at this crazy. And actually, let me take it back. There are some funny stuff that happens also. It's not a best practice, right? But in our UI model, you can have like drag and drop nodes in there, and it's a big JSON that we compile down to SQL commands. Clearly, if you build, like a 20 join node and 10 union nodes within that UI model, well, this is not going to work in BigQuery if you were to run that big SQL commands like BigQuery exceeding limits whatsoever. So then we would still make it work. I'm not saying that it's best practice, right? Like you should split it out into smaller models and abstract that well. But we see some users that are not experienced doing that, which is not necessarily a good thing. But we offer the support because we build intermediate tables in between. When we see, okay, at this point it would fail, then we materialize a table for 10 minutes and then we would materialize the next table. So then you run the SQL command on the already materialized table so it wouldn't fail. And so we would still be able to get them the flat table that they want towards the end. And so that are like enormous, like literally 1,000 node building out the one flat table. That's the one flat table they run the entire company.
In your own experience of building the Y42 product and platform and growing the business around it, what are some of the most interesting or unexpected or challenging lessons that you've learned personally?
I always underestimate the enormous amount of work to, cover such a big product surface. It's a lot for us, to cover, but at the same time, it's very rewarding to try to solve problems on a fundamental level when I keep thinking, hey, how would I solve this problem with a clean slate? And that's very challenging, trying to always be first principle driven, how to design that system that makes sense and that ties together, making decisions of, like integrating with a tool like DBT or not, and really think through all the implications. Interesting, certainly. I think there's one core innovation that we do. We don't innovate on being the best orchestrator or being the best visualization tool. We can't. And that's not what we want. But we innovate on how do we collaborate fundamentally well together. And yeah, there's a lot of interesting things happening. I'm just super excited about WebAssembly lately. Like you can hear from my voice, I think that the way we're doing it using Git as a NoSQL database, I think it could be applied to so many different industries. Like, for example, CMS, content management system. You could like Contentful, I know if you know that tool, like tools that we use on a daily basis that I think they would benefit so much from using that approach. So that's like super interesting for the team.
So for people who are looking for a way to be able to manage their data flows and maybe they need to support non-technical users, what are the cases where Y42 is the wrong choice and they're better suited either building something in-house, integrating the various systems that are out there, or using a different vendor?
So I think in big enterprises that have a lot of different use cases, you should go with very specialized tools such as, Airflow, Dexter, whatsoever. But there's also on a departmental level in these big enterprises, it makes a lot of sense to use something like Y42 that can play along with the data stack that already exists within these enterprises and really enable these underserved, users to be very productive and to collaborate with the engineers that are using hardcore specialized tooling. Then on the other end, there are companies that are just way too small. They don't have a fully dedicated data person. They just rather have the founders. And in these early stages where the product direction is not clear and the requirements are changing oftentimes, I think these companies are even better off not using the modern data stack, but just stick around with a Google Sheets or whatsoever for as long as they can and understand what's happening. I think also for companies that are running on-premise, we operate on the cloud. So if you don't want to be on Snowflake or BigQuery, we cannot serve these clients as well. So to sum it up, very small clients, not a good choice, that don't have a data owner or at least one data hire than companies that run on-premise, and extremely complex use cases where we should be a part of it, but not like running the core infrastructure and orchestrate like millions of jobs at the same time.
As you continue to build and iterate on the platform and expand the capabilities, what are some of the things you have planned for the near to medium term, or any areas that you're particularly excited to dig into?
We're excited to release our V2 that is all about the idea of collaboration, of serving the data engineers also much better because they can collaborate with the business users and the data analysts. So that's something we're very, very excited about for the V2. We keep moving in a direction where we want to go up market, meaning, like I said, it all started with me from trying to make sense and serving this enterprise and building out a scalable architecture to serve everyone in that big company. And now we're slowly moving back there and saying, hey, we are the one tool that, helps you define your metrics, that connects with all the other tools, that enables everyone to really work with their data effectively. And so we want to embark on that journey, to build a very collaborative tool.
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I think the advancement in the data industry, it kind of reminds me also a bit of the front end space 6-7 years ago when AngularJS came out. Now it's Angular and React, and the space is moving towards a direction where it becomes more sophisticated, but people are not in the level yet to fully capture or understand that sophistication. And so I truly believe, and this is why we're building Y42, serve the early adopters or like all the laggards that are slowly coming into the game of data and that still needs the sophistication sooner or later, but don't have the power to harness it yet with the modern data stack. This is the one gap that I keep seeing, and this is the only gap that we're trying to double down on it. But on a more engineering best practice, I think the way of software development is very superior in many ways, and that needs to be adapted to the data engineering space as well. So we need probably more, observability. CI/CD should be, a big game in data. Again, if it's not us, it has to be something else. It cannot be so much friction within all the different toolings. It needs to be something unifying everything together in one, level of version control and some sort of unification, and taking the whole game, embedding all the software development best practices, that process of data engineering as it is right now.
All right. Well, thank you very much for taking the time today to join me and share the work that you've been doing at Y42. It's definitely a very interesting product and an interesting platform, and I appreciate the approach that you've taken. So definitely excited to see how that progresses. So I appreciate all of the time and energy that you and your team have put into that, and I hope you enjoy the rest of your day.
Thank you so much. Have a wonderful day.
Listening. Don't forget to check out our other show, podcast.init, at pythonpodcast.com to learn about the Python language, its community, and the innovative ways it is being used. And visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. If you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers.